Every plastic thing you touch began here, from the cap on your water bottle to the case on your phone, started its life as molten plastic squirted into a steel mold. And that mold, it was born in a place I absolutely love, the tool room. Think of a tool room as a surgeon's operating theater but for metal. It's a workshop filled to the brim with incredible machines, each one designed to cut hardened steel, shape hardened steel, and finish hardened steel with mind-boggling precision. Precision is the king in a tool room is because a mold is a high-stakes puzzle made of steel. The two halves, the core, the cavity. Every surface, every hole, every pin has a critical job to do, and getting it right is the entire ball game. So, a tool room isn't just a place with cool machines. It's a culture of exactness. The people who work there, the tool and die makers, are some of the most skilled craftspeople on the planet. They are masters of measurement geometry and the unique personality of each machine. They take a raw, unfeeling block of steel and imbue it with the intelligence needed to replicate a complex shape flawlessly over and over again. Welcome to UG Mold Tech. Let's start with the workhorses, the machines that do the initial heavy lifting. First up is the lathe. The fundamental principle of a lathe is simple and beautiful. It spins the workpiece. While the metal block or rod is rotating at high speed, a stationary cutting tool is brought in to shave material off. This action makes it the undisputed champion of creating anything round. In mold making, the lathe is the go-to machine for producing parts like core pins. Core pins form holes in the plastic part. Guide pillars ensure the two halves of the mold align perfectly every time. It also makes ejector sleeves and other cylindrical components that need to be perfectly concentric to function smoothly. Next to the lathe stands its equally important cousin, the milling machine. If a lathe is for making things round, a mill is for making everything else. After the mill has roughed out the shape, the part is far from finished. The surfaces are generally correct but still relatively coarse. They lack the precision needed for a high-quality mold. This is where the grinders come in. First, the surface grinding machine. Its job is singular and vital to create perfectly flat, incredibly smooth surfaces. The machine moves the workpiece back and forth beneath a spinning abrasive wheel. With each pass, the wheel shaves off a minuscule amount of material, often less than 1/1000th of an inch. That leaves a mirror-like finish that is exceptionally flat. That flatness is non-negotiable for the parting surfaces of a mold, the faces where the two halves meet. When thousands pounds of pressure force molten plastic into the cavity, those faces must seal perfectly so that not even a wisp of plastic can escape. Surface grinders also finish the tops and bottoms of mold plates and spacer blocks. That ensures when the mold assembly is bolted together, everything sits square and true without internal stress or distortion. Now, all these machines, lathes, mills, and grinders rely on sharp cutting tools. Enter the tool and cutter grinder. It doesn't grind molds, it sharpens the tools that do. It's used to sharpen drills, end mills, reamers, custom-shaped cutters, restoring keen cutting edges to factory new condition or better. The tool grinder keeps the tool room running efficiently. Resharpening in-house saves a lot of money and reduces waste. More importantly, it makes every cut on every machine cleaner and more precise. A freshly sharpened end mill gives a smoother wall in a milled pocket, and a perfectly ground drill makes a cleaner, more accurate hole. This machine is a critical support piece, a force multiplier for shop-wide quality. Quick reality check. While a lathe is great at making parts round, a cylindrical grinder is what makes them perfectly round. This machine is the finishing touch for any critical cylindrical component in a mold. It runs like a surface grinder but for round parts. Core pin, guide pillar, mounted between two centers and rotated. A large abrasive wheel rotates and is brought in to grind the outside diameter. The process removes tiny amounts of material, correcting roundness, correcting straightness, correcting size left over from the lathe. The level of precision achievable with a cylindrical grinder is astounding. We're talking about tolerances measured in the 10,000ths of an inch, 0.0001 inches. A dimension that is a fraction of the thickness of a human hair. This precision is essential for the moving parts within a mold. Guide pillars, bushings, they must have an exact sliding fit, tight enough to provide perfect alignment, but free enough that they don't stick or wear out. Ejector pins. sleeves. The cylindrical grinder delivers the final ultra-precise diameter and flawless surface finish that ensures these parts will perform reliably for millions of cycles. The importance of this machine becomes clear when you consider the dynamic forces inside an injection mold. Parts are heated and cooled, they are subjected to massive clamping pressure, and they move back and forth with every cycle. Any friction or binding caused by an imperfect fit will generate heat, cause wear, and eventually lead to failure. A part finished on a cylindrical grinder minimizes friction and maximizes lifespan, the difference between working and working beautifully. In a modern tool room filled with humming CNC machines, you might still find a few old-school mechanical beasts quietly doing their jobs: the shaper, the slaughter. The holes are everywhere in a mold, and they are not just for putting screws in. This is where the humble drilling machine or drill press comes in. Its job is to create precise holes, and in mold making, these holes serve critical functions. First, there are the holes for the ejector pins. These holes must be perfectly located and perfectly straight. Then there are dowel pin holes, which are used for the hyper-accurate alignment of different mold plates. But perhaps most important are the cooling channels. Cooling is a huge part of injection molding. Molten plastic is hot and it needs to be cooled down quickly and evenly before the part can be ejected. To do this, a network of channels is drilled deep into the mold blocks. Water or oil is then circulated through these channels to carry away the heat. The placement of these drilling lines is a science in itself. If one area cools faster than another, the part can warp or shrink unevenly. A drilling machine, especially a CNC drilling machine, ensures these cooling lines are placed exactly where the mold designer intended, guaranteeing consistent part quality. But what happens when you need to machine a shape that is impossible for a spinning cutter or a drill? For these impossible tasks, we turn to the magic of EDM, or electrical discharge machining. This process uses a controlled electrical spark to vaporize metal. The tool, called an electrode, is brought close to the workpiece and submerged in a dielectric fluid. A spark jumps the gap, blasting away a tiny particle of steel. This happens thousands of times a second, eroding the steel into the exact shape of the electrode. It's used to create fine surface textures like the grained finish on a car's dashboard. It's also used to create deep, thin ribs or sharp-cornered pockets inside the mold cavity. Because it's a non-contact process, it puts no cutting forces on the part, making it ideal for delicate features. No single machine builds a mold. The creation of this precision tool is a symphony, a carefully choreographed sequence of operations. Each machine plays its part, handing the workpiece to the next. It's a journey from rough and raw to smooth and perfect. Now all parts come together: cavity block, core block, ejector pins, guide pillars, plates, screws. They meet on the toolmaker's bench. Final test: everything must fit with a satisfying slide and click. The final assembled tool is ready for the molding machine. It will produce thousands, even millions of identical plastic parts. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more insights.